Okay, this is 6.5 again, chapter 6.5. We're going to continue this. This is synthetic division. Guys, synthetic division is the same thing as, I'm going to put on here, aka synthetic substitution. You remember synthetic substitution? Synthetic substitution, use the upside down backwards L. You have your coefficients here. You had your number that you subbed in here. And then the answer way down here was the answer. Yes?
Yes.
Well, guess what? This is the same thing. Synthetic division, though, I'm going to change the colors here. If we do synthetic division, our coefficients still go across the top. Don't forget, we better have placeholders, right? Now we're not going to call it the number we're subbing in. This is the number you're dividing by. Your dividing by number goes in the place where before we said, hey, evaluate for this number. Here's the cool part. The whole entire bottom part, when you're doing synthetic division, is your answer. Your answer with this now becomes your remainder. So we can do an example. So what we have here is what we need to divide. We need to divide. Now, the last time, I would have said, hey, do long division on this. You guys just did long division. Was it fun?
No.
No. It takes a lot of time. It's not necessarily hard. You got to remember a few things. But it does take a lot of time and space. What if I said you could do all of those problems really efficiently with synthetic division? You'd be happy. And so just like before, when we did synthetic substitution, synthetic division, we still have our polynomial that we're going to divide into by another polynomial. Now the difference between long division, or when you can use long division, and when you can use synthetic division, is the fact that it has to be set up that you're dividing by a linear factor, which means the highest exponent is 1. AKA, I would be able to figure out what makes this part equal 0. What makes this equal 0? What makes x minus 2 equal 0? No, what value for x, would make that 0? 2, right? If you put 2 in for x, 2 minus 2 is 0. So this means I am going to say x equals 2. This is the number that I will use as my sub in, or I'm dividing by. This x minus 2 is the factor that you're dividing into x cubed plus 2x squared minus 6x minus 9. But the value is of that expression is 2. And so what I need to do is I'll put the 2 on the outside. The rest of it is going to follow like we've done. We are going to use placeholders if needed. X cubed is 1x cubed. 2x squared minus 6 minus 9. Those are the coefficients on my polynomial, correct?
Correct.
Now remember, back to those steps, you bring the first number all the way down, and then you what?
Multiply.
Multiply. 2 times 1 is?
2.
2.
2 is 4.
Add going down, 4, and then repeat. 2 times 4? 8. Negative 6 plus 8. 2. 2 times 2. And so the answer we normally would have said would be negative 5. But that's not our answer. That's now our remainder. Later on, we're going to want that remainder to be a 0. This time, it doesn't matter. The question is, though, is not what's the -5, what's the remainder. It's what's the polynomial, when you divide by x minus 2, what's the resulting polynomial? It needs to look like that long division answer. This is how we get that answer. This is a constant, back up. This is my remainder. This is my constant. Those are my x's, and those are my x squareds. They become coefficients again. So the resulting polynomial that I get from here is 1 x squared, or just x squared, 4x, so plus 4x, 2, so plus 2, plus, what was the remainder? It was a -5 out of x minus 2, because that was the factor I was dividing by.